All right, this is really cool. We're going to look at all these beautiful colors that come off of like a oil slick. And I think most of you have seen this, but when you get these sort of interesting colors that happen when you have a thin film of some sort on top of another layer. And so a typical one maybe you've seen is some gasoline that's been spilled, or maybe some oil. In any case, it can be very pretty. And I'll show one in the lab here in another screencast soon. But what I wanted to talk about this example is where we're going to actually have white light coming in. Maybe you've seen I've been using this image a lot, but I've always had it be just one color coming in. But now we're actually going to have all the colors coming in. And think about how, because like sunlight was bouncing off this, that was all the colors coming in. So why are we seeing certain colors but not others? And so that's what we're trying to see in this example. So it helps to know the colors of visible light. So I've included that here. And we have these two equations that we're going to think about for a second. And if we look at our index of refractions, we've got a 1 and a 1.5. So we do have a phase shift on that reflection. And then the 1.5 is going to bounce off of a 1.33. So that's an open reflection. So there will not be a phase shift at B again. So it's similar to what we've seen before. But now we're thinking of all the colors coming in, and to some extent reflecting, and to some extent reflecting again. And now we're going to realize that some of the light keeps on going through. And so the question is, which lights will come out here and be constructive, and which ones go on through? And so the colors that we see as bright are the ones that constructively interfered on the reflections. And so let's see what colors that would be. I've made this question a little different because I've actually given you the thickness of the thin film. So obviously this thickness is varying. This little tiny thin film of, it looks like gasoline on pavement or something like that, is, you know, varying in its thickness, and that's why we're seeing different colors. But I'm going to go ahead and say that this thickness is 500 nanometers, which is in the order of wavelengths of light. So it's a very thin film, which is why we call this thin films. In any case, this thin film is going to be about 500 nanometers, and let's see what colors we would see. So, which of the equations are we using? Well, we have phase shift at one and not the other, so that means we definitely are using these equations that the IB provides. We're not flipping them. And then the other thing is that I'm looking for the visible colors that will have a bright reflection. So we want constructive. So that means we're just going to use this one here. And so M can go from 0 to 1 to 2 to 3 to 4 to 5, etc., like that. And we can look at which wavelengths get solved for here for a given D. And so the other thing we could do is, like, this thickness here could be different than this thickness, and we get the same wavelength for different Ds, but that's not this problem. In this problem, we have D staying constant, and we're looking at which colors are coming off of that same place. And some of these colors you see are pink and things. Those are mixed colors. Those are more than one wavelength that your eye is interpreting. So more than one color is coming out. In any case, let's see what happens here. If we put a 500 in here, the N is again the N in the film, which is 1.5. Again, N in the air, we just don't need that. We assume it's 1 all the time. That's not even in the equation at all. So we put a 1.5 in for N. We put a 500 nanometers here. We're just going to stay in nanometers to keep things easier for us. So we get 2 times 500, which is 1,000, times N, which is 1.5. And then since M is 0, this 1,500 then will get multiplied by 2, because M being 0, this half, when it comes to this side, multiplies by 2. So we get lambda being 3,000 when M is 0. Then when M is, and by the way, you can't see 3,000, so you're not going to see that one, right? 3,000 isn't in this visible range. So let's look at other possible colors that might exist. So the next one would be with an M equals 1, then an M equals 2, and solve for theta each time. And I'm not going to take time to go through that. I'm just going to show the key. So we're using this equation, and we're looking at different M values. So when M was 0, like I said, it was 3,000. I crossed it out because we can't see that. That's infrared, right? Then we had the next one. When M equals 1, you should get 1,000. Can't see that one either. When M equals 2, you get a 600, which is sort of like orangey color. So one of the colors that would come out and be bright here is sort of this orangey color. And the next one is at 428. So 428, sort of a violet, bluish violet color is the other color that's coming out. And so your eye would see both of these colors and interpret it appropriately. So that's kind of cool. Beyond that, we're going to be even smaller, smaller, smaller. And those are also going to be invisible to you in the ultraviolet. And some of those colors might not even be that prevalent in the white light that was coming from the sun in the first place. But in any case, they wouldn't be constructive in the reflection. And so we would get these colors. The other note I had here is just notice that if you use the other equation and use D and put in these to see, well, which ones are dark, which colors don't come out, you can check which colors are actually going through into the water, assuming this is on top of water. And I think I calculated that to be 500 and 750. And obviously all the colors in between are doing something sort of in between being constructive and destructive, some sort of mix of colors, which is why you're seeing this nice pattern here. But I hope that helps us understand some of the things that can happen with thin films. And this is an example where we had white light coming in, and then the D was fixed, but we were asking which colors would we see reflecting off and creating those cool patterns for the thin film. This is the second one. I guess I should have mentioned, hopefully you've seen the other ones first. Good luck, and I hope this is making some sense to you.